Hello friends, welcome back to this lecture series. Here in this lecture we are going to talk about the module transition and inner transition elements in terms of the weightage of the module, what type of questions will be asked, and some of the previous year questions which were asked in the board exam. So let's get started. So this module will be asked for 6 marks where they will ask 3 to 4 questions. There will be one MCQ type of question or very short answer type of question for 1 mark, and there will be 2-3 short answer questions again for 1 or 2 marks togetherly of around 5 marks. So let's see some of the questions. Before moving to the questions, take a glance on this periodic table. Here there are transition metals, what we are going to talk about, and here there are inner transition elements, what we are going to discuss upon. So let's see some of the questions now. This question was asked in March 2022. Which of the following transition element shows maximum oxidation state? So if you check these options, what you can find, all these elements are from the first transition element series or third series of periodic table, from scandium to zinc. General trend of oxidation states in this series is as you go from left to right, from scandium to manganese, oxidation state increases, and as you go further from manganese to zinc, this oxidation state decreases further. So what you can see here, the oxidation state for this manganese is higher, so the correct option here is option 3, and maximum oxidation state we can obtain from manganese, that is +7. Let's go for the next question. Write chemical composition of hematite. This was asked twice, once in September 2021 and then March 2022. So hematite is an ore of iron with the chemical composition that is Fe2O3, that is ferric oxide. But actually this is only of iron, but actually the ore, if you check, that is the mixture of this Fe2O3 plus SiO2 plus some of the other elements like Al2O3 and some of the phosphates. So this ore hematite contains this ferric oxide, and other than that the gang of SiO2, Al2O3 and phosphate. Next short question which was asked is to define the mineral. This was asked in September 2021. So mineral is a naturally occurring substance found in the earth crust containing metals or inorganic salts which can be obtained by mining. For example, this hematite or magnetite, these are the ores of iron. Let's go for the next question. This question was asked in March 2022. What is lanthanoid contraction? So lanthanoid contraction is nothing but the gradual decrease in the atomic and ionic radii of lanthanoids with increase in atomic number. What we found here in the lanthanoid is as you go from left to right, in the series, atomic number increases but decrease in the atomic size. This is what we call lanthanoid contraction. You can understand this better with the help of this graph, which is plotted ionic radius against atomic number. And what you can see from lanthanum to lutetium, what you can see here, ionic radii decreases with increase in the atomic number. Why this is so? This is because of 5f orbitals do not shield the outer 5s and 5p electrons effectively. Hence, increase in the effective nuclear charge takes place. And as the nuclear charge increases, atomic size gets contracted. So this is why this lanthanoid contraction is observed. Let's go for the next question. Why compounds of transition metal ions are colored? This was asked in July 2022. This transition metal ions contains one or more unpaired electrons. What we need to remember? One or more unpaired electrons in the d orbital. These unpaired electrons on absorption of light in visible range get transited from d orbital to the other orbitals. And here the absorption of small radiation from this visible region takes place of certain wavelength, and remaining light is transmitted, and what we observe, the color, is because of this transmitted light. So the main reason, what I told, this transition metal are colored is because of unpaired electrons present in the d orbital. So such type of small questions you have to prepare for from this module, and you will get around 6 marks from this module. So that's it for now. Thank you very much. See you next time.